Welcome to Cortex Insta Level Parallelism lecture, and today we are going to read about what we mean by instruction level parallelism. So, coming down to what we have basically taught, or we have basically already covered, is basically the state space. Remember, there basically the instructions were having the 4 cycles: fetch, decode, execution, and output write. And similarly, the instruction 2 was having the fetch, decode, and execution and output write. So basically, as we can seen, as can be seen from above, we have taken 3 instruction, and there is overlapping of instruction cycle, which means that when the first instruction is getting decoded, the second instruction is getting fetched, etc. Note here that we have taken only 4 cycles for our convenience. That means we are taking here fetch, decode, execution, and output write, whereas some books we have taken they have taken some more than 4 cycle. This potential overlap of instruction is called your instruction level parallelism. This means there is a collision taking place between this fetch cycle of the instruction 2 and the decoding of this instruction 1. And this collision that is occurring is mainly what is the problem with the instruction level parallelism. Now, the amount of branch frequency generally noted in case of this integer programming is basically 15%, which means that around 7 instructions can be executed in between 2 branches. But practically, is it feasible? The answer is obviously no, because while discussing about the pipeline hazards, I have already discussed with you that there is a dependency existing among data. Now, I should say that dependency also exists among phases of instructions, which means that when the second instruction has to be executed, if it depends upon the output of the second instruction, the third instruction has to stop for a moment. That is provided that the third instruction is getting dependent on the output of the second instruction, and then what we call the pipeline stalling will take place. That means if the second instruction is depending on the third instruction, then automatically the pipeline has to stall because the third instruction has not been executed yet. So this how the problem or pipe. So now we can speak of something called parallel. As seen in the previous slide, due to the dependencies between the S7 for I 1000 to xi is their parallelism achieved. Parallelism scenario, we have taken the x as an array where we have taken x now up to 999, x2 we have taken up to 999, and we are just performing, that is x2 is equal to x2 plus y2. So as can be seen in the previous slide, xi is equal to xi plus yi. So x1 will be x1 plus y1, x2 will be x2 plus y2. Like this way, it will continue up to 999 times. Now, when this particular addition of this x1, y1, x2, y2 is taking place, it is just a simple operation whereby the x array is just getting overwritten. Okay, so x1 plus y1, and it is getting once again stored in x1. So it is just getting overwritten up to 999 times with the order of n complexity. Now, as denoted in the previous figure, that is a clear case of parallel execution, because both the arrays are assigned with values and just addition of 2 arrays taking place 999 times, with only case being that array x is overwritten. But what about the following code? Suppose we are doing something called for I is equal to 1, I less than 100, I plus plus, ai equals to ai plus bi, and bi plus 1 equals to ci plus di. So we see that if we have assigned a1 and b1 with certain values, then we can calculate a1 is equal to a1 plus b1, and b2 we can calculate as c2 plus d2. Then a2 equals to a2 plus b2. Now this is b2 was calculated in s2 stage, if you just see, provided that being an array is pre-assigned. So this b1 has been already, this a and b has been pre-assigned, and that is b2 has been calculated as c1 plus d1. So b2 is basically c1 plus d1, and a1 is basically a1 plus b1. So this b1 has to be pre-assigned. So a1 plus b1, this is s1 stage, and that we have assigned a1 and b1 with certain values in the pre-assigned stage, and it was calculated in the s2 stage provided it has been pre-assigned. So there is a loop correct dependency between s1 and s2, that is s1 basically depends on s2. Now why s1 is depending on s2? Because b2 is equal to c1 plus d1. So a2, if I is equal to 2, then a2 will be a2 plus b2, and this b2 has been already calculated at s2. Okay, now this s1 depends on s2, but s2 is not depending on s1. So what you have to understand is that though s2 is that is s1 is depending on s2, but but s2 is not depending on s1, so the loop or cycle is not existing. And here comes a very important point, that is a loop is basically parallel if there is no cycle existing in the loop. Okay, so if a loop is basically parallel if there is no cycle existing in the loop. So if there is a cycle or feedback path, then automatically you can say that this is not a parallel code. So how can we expose the parallelism? We can expose the parallelism just by interchanging the order of sequence of execution, which is also termed as partial ordering. So this is quite very important, is that so this is quite important, is that this basically is partial ordering, because when we interchange s1 and s2, and if we find that there is no cycle found, so automatically we can say that the loop is parallel. So what we have changed the code a little bit, that is a1 we have done a1 plus b1. I think we must go to the basic code. Okay, so a1 is equal to a1 plus b1, and then for loop I equals to 1, I less than 99. Now this s1 and s2 has been interchanged, so bi plus 1 has been made as ci plus di, and ai plus 1 equals to ai plus bi plus 1. So, and then obviously b101 equals to c100 plus d100. Why we have done that? Because I is equal to 99, this b100 is coming on, and b100 has come, so a100 has come, that is a100 equals to a101 plus the a100 plus b100, and then once again this loop will continue with this b100 plus 1. So by b101 I need to reassign it as c100 plus d100. So now we see that s2 depends on s1. Now it has been interchanged, so s2 has dependent on s1 with a slight change in the code, and there is sequential execution taking place, because now when s2 is getting executed after s1, so just a sequential execution is taking place. s2 is getting executed after s1. So completely parallelism is achieved, because even if we interchange, and this is the called your partial ordering, so we can say that this is very perfectly done. Now for I equals to 1, I less than 100, I plus plus, ai plus 1 equals to ai plus ci. Let us term this as s1 stage, and bi plus 1 is equal to bi plus ai plus 1. Now what about parallelism? Now here you see this is quite interesting, that is a2 will depend on basically a1, and b2 on the other hand depends on that is b1 as well as a2. So b2 is getting dependent on b1 as well as a2. So already you can see, so b2 is depending on b1. So all the states s1 and s2 are, you can say that they are having a self loop, because a2 is depending on a1 plus c1, and b2 is depending on b1 plus a2. So s2 is depending on basically that is s1, and s1 is once again depending on itself. s2 is depending on this s1, s2 is once again depending on that is s1, and s2 is once again depending on itself. So you can see very well that there is a cycle which is formed. There is a same self loop which is being formed right out here, and due to this loop the parallelism is not achieved. So no parallelism is achieved. Now how can we avoid this basically this parallelism? One thing which we have discussed today is the loop level parallelism, and rest of the, that is the next class or the next video lecture, we shall discuss about the vector processor and how it helps to how it helps to avoid this parallelism. Okay, and last but not the least, basically, uh, thank you everyone for your patience hearing, and you take care of yourself and as well as your family members due to COVID-19. And soon we'll be back with more lectures. It will be intimated through your group mail ID. Every details will be given into your group mail ID. Thanks for your patience once again. This is Abisa calling from MCKBI.